Good evening, one and all. This is day 3 of our Java programming course. So, before we begin, as usual, I'll quickly revise the previous points that we have seen within 2 minutes. So, let us begin. So, we have initially seen the identifier rules, that is, the naming conventions, what we can give and what we cannot give as the variable name. Identifier name may be variable name, function name, class name, any name that you use in your program. And what is allowed? Underscores are allowed, dollar sign is allowed, letters and digits are allowed, but digits cannot be at the beginning. Spaces are not allowed, and keywords cannot be the names of your variables. So we have seen all this in detail, the list of keywords and reserved words, then valid and invalid names. And we have seen what is declaration, what is initialization. So declaration means writing the data type along with the name. For example, this
Sir,
line.
voice is a bit low.
Okay, 1 minute. Is it okay now? Am I audible now? Hello?
Yeah.
Yeah,
Yes.
okay. Sorry, I had some network issue. We will continue now. So I was explaining about what we have seen. So we have seen that we can declare a variable and then we have to initialize it, or we can do the same, both of these things on the same line. So this example that you can see as string my job is declaration, and then the next line is what? Initialization. Now initialization, sometimes it is called as definition also, because you're defining the value of the variable, and you can do it together as per this single line. So this much we have seen last time. Now I've also shown you that we should not redefine or redeclare the same variable. For example, here I've said declaration string my job. Next line again I'm declaring the same variable my job. So what will happen? It will give you an error. But you can update the value how many ever number of times you want, but do not declare the same variable again and again. Okay, now we have seen the data types. So in data types, let us see some more details about that. So in this handwritten notes, data types can be of two types broadly. One is primitive, which is also called as intrinsic or basic data type, and the other is called as non-primitive data type or derived data type. So in this primitive or basic data type, we have seen byte, short, int, float, long, double, char, boolean. Now, what is the difference between them? Like some characteristics about the data type, let us see. For example, Java is statically typed. Statically typed means at the time of writing your program, okay, at the time of writing your program, at the time of developing your program, that time you must specify the data type. For example, just now we saw that while I'm writing my program, I must write string my name to indicate that my name is a variable which will store a string value, right? Means at the time of developing the program, you can call it a static time or statically. And if it is at the runtime, that means dynamically, if the program will understand what is the type of the variable. For example, in Python, we do not write int a equal to 5. We directly write a equal to 5. That means at the running time or at the dynamic time, it is called, at the runtime of the program, it will understand that what is the type of the data, what is the data type of that variable. Okay, at the runtime, it will understand. But here it is not possible. We must write it at the time of developing a program, that is at the static time. So that is the meaning of statically typed and dynamically typed. Statically typed means at the time of developing the program. Dynamically typed means automatically the compiler or interpreter will understand the type of the variable. So there are 8 basic types or 8 primitive types. So we have byte. Okay, first we know that we have char, boolean. Then to store an integer value, there are 4 ways. Either use byte, short, int, or long. So what is byte now, and how is it different from the others? Byte, the range of the values of byte goes from -128 to 127. Now, how to remember this range? Okay, even in Python, you might have studied these ranges, but how can you actually remember this range? Is by a particular formula, which I will discuss now. Okay, let me just open the whiteboard. So this range means what? Now we know byte means it will store, a byte will store 8 bits. Okay, 1 byte is equal to 8 bits. So the size of byte is byte means it will store 8 bits. Now, if it stores 8 bits, means it will help us to understand the formula. See now, when I'm saying 8 bits, that is 1 byte. Now this range, it goes from a negative to a positive. Okay, means you can have even negative integers as well as positive integers. So the formula is, you must, the formula is, you must write it this way. You have to write minus 2 raised to n minus 1, comma 2 raised to n minus 1 minus 1. Now what is this n? What is this 2 raised to and all that? So the negative range is minus 128. As you can see here, it is minus 128. And n is equal to 8 over here. There are 8 bits, so n is equal to 8. If there were 16 bits, n is equal to 16. Okay, so n is nothing but the number of bits. Okay, not bytes, bits. So if I substitute the value of n in this formula, what I will get? I will get minus 2, 8 minus 1. Okay, 8 minus 1, comma 2 raised to 8 minus 1 minus 1. Now if I further simplify this, I will get minus 2 raised to 7, 2 raised to 7 minus 1. Now 2 raised to 7 is 128. Okay. For example, 2 raised to 0 is 1, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, then 64, 128, 256, 512, 1024, and so on. You keep on incrementing. So 2 raised to 7 is equal to 128. And here what it is, 2 raised to 7 minus 1 means 2 raised to means 128 minus 1. Okay, we have come up till here. Let us further simplify. What we'll get, minus 128 comma 127. And this is the range, right, that has been written in this PDF. So the range of byte goes from minus 128 to 127, which we have derived from the formula. Is this clear how I have derived it? Is it clear?
Yes.
Everyone?
Can you explain it one
Yes.
more
Yes.
time, please?
Okay, sure. One more time. Just a minute. So if n is equal to 8 bits, okay. Now why I'm saying 8 bits, because the size of byte that the byte variable will occupy in the memory, byte variable will occupy 1 byte. 1 byte is nothing but 8 bits. Okay, 1 byte is equal to 8 bits. That means n is equal to 8. Okay, how many ever number of bits are there, that is equal to n. Now the formula is minus 2 raised to n minus 1, comma 2 raised to n minus 1 minus 1. Okay, so this one is the lower limit and this one is the upper limit. Okay, now let us substitute the value of n. So here n is equal to what? 8. So I'll put it here. So 2 raised to n minus 1 means 8 minus 1 means 7. And here what we have, 2 raised to 8 minus 1, that is 7 minus 1. Let us further simplify. 2 raised to 7 is equal to 128. Okay, you can calculate it later, but it is 128. And then 2 raised to 7 minus 1 will be how much? 127. That is how we get the lower range and the upper limit, lower limit and upper limit. Now is it clear how I got this?
Yes, thanks.
Okay, welcome. So this is not only for byte. You can use the same formula for all the data types. So let us apply it for short now. Okay, so byte occupies 1 byte. That is why n is equal to 8 bits. Now let us see for short. Now for short, the size is 2 bytes. Okay, for short. So whenever you store a value inside a short variable, it will occupy 2 bytes inside the memory of your computer. I repeat, whenever you write short a equal to 12, suppose, then this 12 will be represented in the form of zeros and ones, and it will occupy 2 bytes inside your memory. Okay, so since it occupies 2 bytes, 2 bytes is how many bits? Anyone can tell me?
16.
Yes, 16 bits. So here n is equal to what? 16. Yes,
16.
so n is equal to 16. Now we'll apply it in the same formula. The formula is minus 2 raised to n minus 1, and the upper limit will be 2 raised to n minus 1 minus 1. Okay, now n is equal to what? 16. So let me write it a little directly. 16 minus 1, that is 15. And here it will be 2 raised to 15 minus 1. Now, if you calculate 2 raised to 15, whatever the value is, just let me use my calculator. 2 raised to 15. Okay, it is 32768. And minus 1 means 32767. Okay, and here we have the minus sign. That means the range of values that you can store in the short type of variable can go from minus 32768 to 32767. Means what? Suppose I write short a equal to 32161. Now 32161 comes within this range. Do you agree with me? Yes or no?
Yes.
Yes. Okay, so this value, if you store in
Yes.
short a, yes. So if you store this value in a, then what will happen? It is accepted. No error will be given. Now suppose I store, instead of this value, I am saying a is equal to, suppose 33152. Now this value is within the range or outside the range?
Outside.
At the
Yes.
range.
Yes. So it will give you an error. Okay, this is the meaning of which range of values are accepted. Only this range from minus 32768 up to 32767. Okay, including them, it will be allowed. Other than that, not allowed. For example, if I write a is equal to minus 45678. Now this is also outside the range, right? So this will also give you an error. But suppose I write minus 26161. This is within the range, so allowed. So I hope you understood what is the significance of this range. It indicates that what value will be accepted in that type of data type. Okay, so you can apply this formula for everyone, not only byte short, for int also. Now int occupies 4 bytes. 4 bytes means how many bits? Anyone can answer?
32.
Yes, very good. 32. Yes. So you can apply the formula. Okay. Here they have done little, means 2 raised to 32 upon 2, all that they've done. But you can go with the formula which I have just now showed you. Okay. So same for float, and then long also you can try it out, double and char. Now you might have seen something like, okay, just a minute. Okay. Okay. Yeah, so that was about the range of the values that are accepted. Now, so this is for integer that I've prepared the slide. This up to this. So you told me that just now integer means 32 bits it will store. So you can apply the formula for n is equal to 32. You'll get this as the lower limit and this as the upper limit. So same thing is written here. Numbers greater than the upper limit and lesser than the lower limit cannot be stored. Okay, so that was about the range. So here are some more examples. So which one will give you an error? Only if it is greater than the max and if it is lesser than the min. Okay, you can see this later when I send you the slide. Now how you can print the values. Now here I have an integer I1. Okay, the name of this variable is I1. It stores the positive value, positive integer 5. And then I2 stores 10. Now if I want to print a variable, simply inside the print ln, I must give the variable name. Okay, I must give the variable name. Now if I, for this, what will be the output? The output will be 5 because I1 is equal to 5. Now suppose I want to perform an operation on this. I want to add 2 to this 5. So what I'll do, I'll take I1 and write plus 2. So I1 plus 2 is actually an expression, right? Expression is nothing but a combination of operators and operands. Operator means your plus, minus, division and all. And operand means the data or the value or the variable name. Okay. I hope you know this, operator and operand. Operand is nothing but the data or the value. Operator is the symbol that you give, plus, minus, plus, plus, and all those. So if you want to print the variable, you can do this way. Similarly, if you want to do a operation between two variables, suppose I1 minus I2, okay, you can do it directly like this, and you can print it. Now here what they've done, the expression they've written inside the println statement. Okay, the expression has been written inside the println statement. Now there's another way you can do it. You can write int, suppose I3 is equal to I1 minus I2. So what will happen? First I1 minus I2 will happen. That is 5 minus 10 minus 5. That minus 5 will get stored in I3 variable, and then you can print the I3 variable. Right? Any doubts still here?
No, sir.
Okay. So similar for byte, we just know, sir, this is the range. And suppose you are giving a number which is outside the range. For example, B5 equal to 128. It will give you an error because upper limit is 127. 128, 129, and so on is not allowed. Okay, similar for the negative range. This is for short. Okay. Range of data types is same for all language. Usually it is same for all language. C++ and Java, there's a difference in char actually. Character in C++ is 1 byte, but in Java it is 2 bytes. So in C++, n would be equal to what? It is 1 byte, so 8 bits. So n is equal to 8. But in Java, since it is 2 bytes for char, n is equal to 16. So then your size will also change because in the formula, the value of n is changing. So it is not for all the data types, only for some it may be. For example, in C++, integer occupies 4 bytes. In Java also it occupies 4 bytes. So not always. For some it may be, for some it is not. Now let us see long. Now for long, in order to indicate that the value is in the range of long, okay, to indicate that the value is in the range of the long, then what you'll do, you must write a L over here. Okay. For example, if this is the range, the number 926, whatever, and at the end L, either capital L or you can give small l to indicate that this value is a long data. It will tell the compiler that the number is a long and not an int. So what is the meaning of this is, if I'm writing int a equal to 5, okay, so 5 will be stored as an integer and it will occupy 4 bytes because int. But when you're writing long a, suppose, and you are writing the number, okay, whatever number, but at the end compulsory you must write L or small l. Now what will happen if within an integer you write a very big number which is outside the range, and if you give L over here, what do you think? Will it be accepted? You're telling that int a equal to such a big number which is in the long range, and you're writing L over here. Should it be accepted? Will it give error? What will happen? What do you think?
It should give error.
Error.
Okay. So you're right. Okay. It will give you an error because the size of int is less than that of long. So even if the value will get stored, then there'll be a loss of data, and that is not desired. So it will give you an error. Okay. So that is the reason. So here some examples are there. Long L1 is equal to, okay, this is in the negative value. Okay, this is the negative value, and you are using capital L. So it is fine. And here you're doing it same thing, but you have forgotten to give the L. So it will give you an error. Now here, this range is actually what? It is it is actually not, means long can store this size of values. Okay. But this is actually coming in the range of integer. Okay. So if you are storing an integer range inside a long, that time no need to give L. Only if the range is exceeding the integer. See, first you have byte. Let me show you clearly. First you have byte. which occupies 1 byte. After that, what is the next greatest? You have short. Next greatest is int. And finally, you have long. So if you are storing a byte inside long, means if you are writing long a equal to, suppose, 25. Now this 25 comes in the range of byte. So this byte can be stored directly inside this long. Okay, suppose you write 251. Suppose it comes in the range of short. You can directly write it inside the long. If it is an integer and it is in the integer range and you're storing it inside a long a, then you can directly write it. But if it is exceeding all these ranges, you have a very big number, which is in the long range, then it is compulsory to write L at the end. Are you getting it? Any doubts? Have you
Yes,
understood?
sir. One doubt.
What doubt?
Sir, why don't we always use long to store any value?
Because it will be a waste of space, right? Because, okay, good question. See, if your long ka range is what? I have written it in the PDF here. The range of long is 8 bytes. 8 bytes means what? 8 into 8, 64 bits. Okay, so 64 bits. And suppose the data that you want to store is in the byte range. Byte range is what? Minus 128 to 127. So suppose the number is 100, then it falls in this byte ka range. That means 1 byte is sufficient to store 100. Byte means what? It will occupy 1 byte in the memory. 1 byte is sufficient to store 100. Then why should we waste 64 bits? That is 8 bytes. Why to waste 7 bytes actually? Because 1 byte is compulsory for 100. Okay. So other 7 bytes will get wasted, right? If we use long. If we are using long, just to store 100, we'll waste the remaining. That is 8 bytes will be used for 100 to store 100. But if we are using byte, you can store that same 100 and there'll be no change, right? 100 is 100 only. If you use 1 byte to store 100 or if you use 8 bytes to store 100, it will be same. But what is the challenge here? You'll waste more space if you use long for such a small value. Are you getting it?
Yes, sir.
Okay. So good you asked this question. So now there are some examples that how you can convert between byte, short, int, long. Okay, so this is important. It is actually under the concept of type conversion. So as I said, byte is the smallest range and you go up to long. So byte, it occupies 1 byte, short occupies 2 bytes, int occupies 4 bytes, long occupies 8 bytes. So if you are getting confused like how to remember this 1, 2, 4, 8, it is actually 2 raised to 0. This is 2 raised to 1, 4 is nothing but 2 raised to 2, and 8 is nothing but 2 raised to 3. So powers of 2 defines the size of these data types. I hope you have understood this. Now, if I'm writing byte b1 equal to 5, I've declared and initialized on the same line some variables. I have a byte variable, short, int, long, and they're storing 5, 10, 20, 100 respectively. Now I want to update the value of L1 variable, right? I have declared it, I have initialized it, but now I want to change or update the value of L1. So I'm going to store some value in L1, okay? That value I will get by solving this expression, suppose. What is this expression? The expression is L1 is equal to B1 plus S1 plus I1 semicolon. Now see carefully, B1 is a byte. Here I have written B1 is nothing but it is a variable whose size is byte or whose data type is byte. S1 is of short type and I1 is of int type. So here you have a mixture. You have different sizes and you are going to finally store it in a long type of variable. L1 is long, right? So inside a long variable, you are going to store some expression and that expression has different sizes, different ranges. So what is the actual size? How to understand that? So that I'll show you now. See, always remember, whatever is at the right side of the equal to, solve that first. You'll get some final value, and that final value will be stored in the left-hand side variable. Okay. And why that is, we'll see that in operator precedence and associativity rules. So B1 is a byte, S1 is a short, I1 is an int. Now, which is the largest among this? Between byte, short, and int, which has the largest size? Can you tell me?
Int.
Yes, very good, excellent. Int has the largest size. Okay, maximum sizes of int. Among these three, among the right hand side, int has largest size. So everything at the right hand side will get converted into an int variable, int type. That means b1 is currently a byte. Its size will get updated or get changed to an int size. That means byte is becoming an int. Okay, the size of int will be given to b1. Similarly, s1 is currently a short. It will become also an int. And I1 is an int only. It will remain as an int only. Right? So whatever sizes you have at the right hand side, all will get converted into int. And then finally, this int you'll get at the right hand side. Everything is in the int, right? So what will happen? b1 is equal to 5. Then you're doing plus s1 is equal to 10. Then you're doing plus I1, that is 100. So 110 plus 5, 115. So now this 115 is the final value of my expression at the right hand side. Now this 115 is an int. Okay, it is an integer. It is not byte short. It is an integer because we have said that everything is getting converted to int. So 115 will be stored as an int value. And we know that if you have a long variable, yeah.
It will be 5, 10, and 20 now.
Oh, sorry, I took 100 over. Okay, sorry, 20. So instead of 100, it is 20. Thank you. So 20 and 10, 30 and 5, 35. Okay, so not 115, 35. Okay, sorry. So the expression will be equal to 35. And this 35 will be an integer value. It will be stored as an integer. Now this integer has to be stored in long L1. So this is an int now, and int can be stored inside a long. What I mean to say, if you have an integer, you can store it inside a long. Means if the right hand side is a smaller size, okay, if the right hand side is a small size and the left hand side is a bigger size, then you can store small things inside big things, right? If you have a small box, you can store it inside a bigger box, but you cannot store a big box inside a small box, right? I hope you get this analogy. That means at the right hand side, if you have a smaller size, it can be stored inside a variable which can occupy bigger size. So what does this mean is, this is same for all the cases. For example, inside a long, you can store a short. Okay, if at the right hand side, suppose everything gets converted into short, you can store a short inside a long. If at the right hand side everything gets converted into int, you can store an int inside a long. If at the right hand side everything gets converted into byte, you can store the byte inside the long, right? Because at the right hand side, these sizes are small compared to the size of the left hand side. Okay, always remember, smaller boxes can fit inside bigger boxes. So this was about long. Now what about short? If at the left hand side you have a short variable, then can you guess what all sizes will accommodate inside short? What do you think?
Byte.
E-byte.
And which else? Short also, right? Short can be stored inside short and byte can be stored inside short. That means less than or equal to size, I mean to say. Okay, short can be stored inside short, and below short, whatever is there, that is byte, can be stored inside short. Now similarly, can you tell me for int, if at the left hand side you have int, what are the possible sizes that will fit inside?
Byte, short, and
Int, short,
Byte,
byte.
short, int.
Excellent, very good. So less than equal to, everything will get stored. Can I store long inside int? No. Okay, so this was about the how the type conversion is happening. And this is happening automatically, right? You do not have to do anything on your own. Whatever is at the right hand side, compiler will do it on its own. It will find out that which is the largest size, then it will convert everything to that size, and that size will be stored inside the long, okay, as a long. Okay. Similarly, the next example is for int, which I just now showed you here, and then for short. So inside short, I'm storing b1, means byte. Byte inside short is valid. So this was the size. So byte is smaller than short is smaller than int is smaller than long. So a long can store int short byte, int can store short and byte, short can store byte, and byte can store byte only. Okay. Now another example. If I'm saying I1 equal to L1. So I1 is what? Int. I'm saying int should store something which is long. This is not valid. Okay, it is not okay. because I said less than or equal to is possible at the right hand side. Similarly, S1 equal to I1. That means it is trying to do short is equal to int. This is also not valid because int is greater than short. Similarly, byte is equal to int. This is also not possible because int is greater than byte. Okay. So I hope these examples have cleared it for you. And
Sir,
now, yes.
sir, can we break long into two parts and then store it in int?
No, that is not possible because in your long you have the size of 8 bytes and the total size will be in the form of zeros and ones. So if you break it, in some cases there will be memory loss, in some cases there will not be memory loss. For example, if you're storing 12 inside the long variable, for example, if you're storing 12 inside the long variable, then 12 in zeros and ones is what? If you're converting 12 into binary, that is using 8421. So 1100. This is how many? This is 4 bits. Means this is actually half a byte. So if I want to make it 1 byte, I have to append, I have to add these zeros at the beginning. So this will become equal to 1 byte. Okay, this is 1 byte. Now remaining 7 bytes also will be there for the long. So all those places have to fill zeros. Okay, in this case, suppose you want to divide, suppose by dividing the number or something, maybe it will divide over here somewhere. So at this part will have the 12, this part will have all the zeros. So you may consider the right hand side part. But suppose the value is big. Okay, suppose the value is occupying this much size. Then suppose this will be in one part, this is another, this is in another part, then it will not be correct because it will not be 12 as a whole. Okay, so you cannot divide the value like that. You cannot store it half in different variables. Is it clear?
Yes, sir.
Okay. Now just
Hello.
remember, yes,
Bhaiya, actually I have a doubt.
yes,
If in int we are storing we are having an addition of two int numbers, that is suppose I1 equals to I2 plus I3,
yes,
and those I2 and I3 are so long that if we add them it exceeds the maximum limit of int.
yes,
So what will the output be? Will it show any error, or
yes, it will show
it
you
will?
an error. So
Okay.
since you are saying int I is equal to a very big int means uh, suppose the range is exceeding. So what happens usually when you're adding two numbers which are integers? Suppose let us take the maximum 32767. Suppose you're adding 32767 with 32767. So as you can see here, the size is exceeded. Okay, so this comes under the long 65 whatever. So you're trying to store a long inside a int, or you're storing a big data inside int which does not have the capacity, then it will give you an error. Okay, so you must be careful about this thing. So if you are sure
Okay.
data is very big, you can go for long. Okay, so now you can also, just for your understanding, we'll see some programs also now. What is a package? Like you might have seen import package at the first line of your Java program. So package is nothing but a collection of classes, or you can say a collection of modules or a collection of Java files. Okay, so each class can have some functionality, and a number of classes or number of interfaces that we'll study together forms a package. So a package will have some predefined code which you can directly use in your program, or maybe one program you want to link with another program. So suppose the problem statement is you have to add three numbers, okay, which are integers. So one way is this one. You'll take, now here what I'm doing, I'm directly assigning the value. I'm directly initializing num1, num2, num3. What if you want to take input from the user? Means the user will tell which numbers he wants to add. So that we'll see little later. For now, this is called as hard coding. Means inside your program itself, you are initializing. Means this is static. It cannot change, right? If the user wants to add 6, if the user wants to add 12, 13, 14, then this program will not work. Why? Because this program can add only 5, 6, 7. If you want to make this program to add 12, 13, 14, then you have to take input from the user, so that each time the value of num1, num2, num3 will get changed. But for now, this is a simple program in which you want to add 5, 6, 7 only. So you have created 3 variables. So this is declaration and this is initialization. And then you'll add it using this plus operator, num1 plus num2 plus num3, and you will store it inside int sum. And then this is sum is another variable whose value you can print. Now tell me one thing. Here I'm printing, I want to print the value of sum. So which statement do you think will give me the correct output? There are 2 print statements.
First.
Yes, correct. And what will I get at the output of this print statement? What should be the output?
Some.
Some. So what?
Yes. But why, can you tell me?
Because it's in double inverted comma.
It is in
Yes,
string.
very
It's in
good.
double
Yes,
quotation.
correct. Very good. So sometimes what happens, people, if they want to print, if they want to print the value of the variable, by mistake they put the double quotes. For example, if you are typing like this, the sum is. Sometimes people by mistake they think that sum will print the value of sum, but that does not happen. So you need to be careful in what is inside the quote and what is outside the quote. So let me execute this program. To execute it, I need to either right click in this workspace and then click on run. Okay, for the first time. And then second time onwards, what happens? Whichever, see, there are multiple files over here. So whichever file you run, then it will get, its name will come over here. Okay, and then directly you can click on this button. Second time onwards. First time you must do right click and run. Second, third, fourth time, if you want to do, use this. Directly you can run it from here. So the output has come is this hello all is coming from here. Okay, this hello all. Okay, so you can comment it if you want. And the shortcut for commenting any line is, I'll show you. Okay, let us first see the output. So the sum of these numbers, are, this statement will get executed. Then what will happen? This variables will get created. Then the sum will be calculated. It will be stored in some variable, and then you'll print the value of sum. Okay, so the sum of these integers of these numbers is, and then the sum is getting printed, and then as you told me, this sum, the text is being printed. Now the shortcut to comment certain lines. Now if it is just one line, you can bring your cursor here and put / 2 times. But what if 2-3 lines you want to comment out? Then select all those lines like this, and then on your keyboard, control / means control also you have to press and / also you have to press on your keyboard, and then all these lines will get commented together at a one shot. If I want to uncomment, then again control /. See, the comments went. Okay, I hope you got the shortcut. It is very handy if you are writing multiple lines of code in the same program and you want to execute a particular part. For example, I'll show you here. See, I've solved the questions, question 1, question 2 and all. I want to run only question 4, suppose. Then I'll select the lines of question 4 and uncomment it. See, so simple it becomes to uncomment and comment. Okay. So this was about that shortcut. And this shortcut is valid for number of IDEs. So even for VS Code, it is applicable. So this was a simple program. Next, let us start off with operators. Okay, so operators are nothing but it will help you to find the value of a particular expression. Okay, so if you want to find out 7 plus 11, then you are using the plus operator over here. So as I said, operator is nothing but the symbol that you use, and this is the data called as operand. It may be a variable name also, maybe 7 plus a you want to do. Okay, and you'll get the final result. So result is usually written, it will be computed or found out at the right hand side, and it will be stored in the left hand side. Okay, usually. Now there are different types of operators like arithmetic operators. Examples are plus, minus. You use asterisk for multiplication. This is for division. What is this percentage used for? Anyone?
Remainder.
Division.
Yes. What did you say? What division?
Mod.
Yeah, mod division. Okay. Or you can simply say modulus operation, or you can say to find out the remainder. And this plus plus is called as increment, and this minus minus is called decrement. Now increment decrement is actually a shortcut to increase the value by 1 or decrease the value by 1. So that we'll see later. Then there is assignment operator, means you're equal to. Now equal to, when you write, it does not mean that you're checking left hand side equal to right hand side. What equal to means, when I'm writing int a equal to 12, means the value 12 is getting stored inside a variable, inside the memory. Okay, that is the meaning of single equal to. If you want to compare left hand side and right hand side, whether they're equal or not, you'll use double equal to. Okay, it is same for most of the languages, so don't forget it. Then other assignment operators are plus equal to, that we will see. Then comparison may be less than, greater than, less than equal to, greater than equal to. Then you have logical operators, like if you want to find whether true and true, false or false. Okay, do you all know logic gates? Have you all studied it?
Yes.
Yes, sir.
Yes.
Yes.
Okay, so I don't have to explain much about this, you already know it. Then you have bitwise operator, means bit by bit you want to perform the and or not operations. Okay, so let us see one by one. Also note that the arithmetic operators, plus, minus, this modulus, plus, plus, minus, minus, all these cannot work with booleans. Okay, boolean is what? True or false. You cannot use it there. True plus true, you cannot do like that. And this mod operator, that is your percentage that you say, is only for, it cannot work for floats and doubles, it will only work for integers. So these are very important, because sometimes in competitive programming, what happens, if you want to find out the remainder for float divided by float, you cannot, some people use this modulus operator and then they get error, then they are not able to identify which is the error and all that. So there are special functions in order to do float divided by float. Okay, that we will see later. So remember that mod is only for integer divided by integer. Then this is later on we'll see. Now, if you want to express such expressions, what you will do is, see here what I want to express in my program. Now in mathematics, you may write like this, x minus y upon 2. But in programs, you cannot write like this. So how you will write in your program? You will write it like this. You can write it as, suppose I want to store the value of this expression inside a variable. Then I will write x minus y, put it within brackets, and divided by 2. So what this brackets indicates, it indicates that first solve x minus y, that is the numerator, and then divide whatever the result is of x minus y. Suppose x minus y is 5, then 5 divided by 2. Okay, so your brackets play a very important role. If you don't give brackets also, there are certain rules according to which it will execute. That also we have to see. Similarly, you can try for b square minus 4ac, how you will do it. Let us see. So if you want to do b square, now in Python, if you want to do a raised to b, then you have this kind of facility. So it is b raised to z here. But in Java, it is not possible. You have to use certain predefined function. Or since this is square, it is easy to do b into b, right? Do you agree with me? B into b is easier to do, right? Because it is square.
Yes.
Yes.
Yeah.
Yes.
So you can give a bracket. If you don't give a bracket, what happens, that we'll discuss later. And then 4 AC. Now you cannot write directly 4 AC. You must give multiplication sign between this. And then give bracket for this. So if you know certain rules, then you don't need to give this brackets. Okay. But as a beginner, you should know this. And then this whole thing is my numerator. So whole bracket I will give. And you don't give square brackets, means don't give this, don't give this. Okay. It will not work. You have to give only round brackets. And then divided by, within bracket, 2 into a. Okay, I hope you have got this. Similarly, you can try these also. Now we have seen byte plus short, what will happen, like what it will be converted to. Then we have seen byte plus short plus int and so on. Now one more thing that you need to remember is, the following table summarizes the resulting data types. So suppose you have c plus I, means char plus int, then it will be converted into int. How it will happen, we'll see in the program. Okay, char plus short, it will be converted into int. Now byte plus short And if the so byte plus short, what will happen? Greater is short, so it will get converted into short. And if the left hand side is an integer, suppose int a equal to byte plus short, then the right hand side will get converted into short, and then while storing that short inside the left hand side, it will get converted into int. Okay, so our main focus is to finally convert everything into the left hand side data type. Okay, so you remember that. And then long plus double, um, it will get converted into double. Okay, there are some different rules for when you have int and double, or int and float, or short and float. Okay, if you have byte, int, short, long, they have certain different rules, so you need to remember that. And usually when we write high level programs, we usually have to take care of all these things. Okay, then increment, decrement, these things we can see later on. So I think enough for today. If you have any doubts, you can ask me now, and quickly put your attendance in the chat box. And if no doubts, you can leave this meeting. Thank you for attending. So did you learn something new today? Was it interesting? What was your experience?
Yes, sir. It was interesting.
Okay,
Interesting, sir.
thank you. Thank you. Very good. Any other doubts you have, you can ask me.
Sir,
Yes.
if we want to print two variables, then how can we print?
Yes. So that you have to use a particular syntax inside the println. So I'll just show you now since you've asked. We'll see that next time. I don't have it, I think. So. 1 minute. See, for example, here I'm going to print the value of A variable, B variable, and C variables. You must separate it with the plus. Now, why plus? Because it acts as a concatenation operator if you're using it with strings. That means if you have a string over here, and after that you have an int value that you want to print, then it will get converted into string. And if everything is a string, plus will act as a concatenation operator. So this is actually, we have to study in detail, so that we will do next time.
So minus can't be used, right? As
No,
we
no,
use in
minus cannot
Python.
be. No, minus cannot be used. Anything else you want to ask? Anyone? Okay, then if you have any other doubts, then you have the, yes, you want to ask anything?
Byte data type only stores integer value.
Byte what?
Byte data type
Huh.
stores only integer value or anything else also.
It can store only integers. It can store minus integer or positive integer, but within the
Uh,
range.
and is it present in C++ also?
No, no, it is not there in C++.
Okay.
Okay. So if any other doubts you have throughout the week or anytime, you have the link for the uh, feedback form or doubts form that I've shown over here. Okay, this link. If you click on this, you can attach a screenshot also if you want, if you're getting any error in any program, and I will respond to that. Okay. And if you're not able to access this sheet, just send your email on the group and try to fill the registration form. And if you have any other doubt, you can tell me anytime. If you want to message me personally also, that is fine. So I'm ending this meeting now. Thank you.
Thank you.
Welcome.
Thank you.
Welcome.